Alright, we're down to the last few questions. Question number 36. You throw a water balloon. Oh, this sounds a lot like 35. You throw a water balloon from a balcony to a pool below. The height of the balloon in feet is modeled with the function h of t is equal to negative 16t squared plus 8t plus 80, where t is time in seconds. How long will it take for the water balloon to hit the pool? First thing we notice is, unlike 35, remember on question number 35, they gave us the velocity, the starting height, and the a value. We had to build our equation. 36 is a little bit easier because they give us the equation. And also notice how long, we know it's going to be time. How long will it take for the water balloon to hit the pool? We know that is an x-intercept. So I'm going to solve this equation. It's a standard form quadratic. We're going to go ahead and use quadratic formula again. Again, if you want to try to factor, you can. I don't think this is factorable. And you could use complete the square, but it might be a little tricky to do with that 80 divided by negative 16. So let's use quadratic formula. We're going to write our equation over again and set it equal to 0. That's a rule of quadratic formula. Get every term to one side of the equal sign and set your y value equal to 0. And now we can find our a, b, and c terms. Next, you're going to find the discriminant. I'll go ahead and give you that, but to get credit for this worksheet, you're going to have to work that out. The discriminant in this question is going to be 5,184, and your solutions will end up being -2 and 2.5. So remember, we're looking at time, so all negative numbers are taken out, and we're left with one positive solution of 2.5. And that tells us, if we're looking at time, it's taken 2.5 seconds for the water balloon to hit the pool. Make sure you write that as a complete sentence, and somewhere in your solution you should be mentioning the time it takes to hit the pool, which is 2.5 seconds. Alright, let's take a look at the next one. A diver jumps from a platform to a pool below. The height of the diver in feet is modeled with this function, where t is time in seconds. How long will it take for the diver to hit the pool? I can say again, this is definitely x-intercepts. There's nothing about maximum height or time to maximum height, so they're certainly not talking about the vertex. So as we normally would for quadratic formula, since I'm going to use that one again, I'm going to rewrite my equation. This is very much like the last one. Oops, that should be an x. Let's make that look a little better. That's 10x. Oh, sorry, 10t. Some of you have asked me in class, when I'm doing this, Mr. Z, can I just go ahead and change all the t's to x's? Because I just feel better working out that way. It's totally fine if you do that. You can change the variable. Okay, equals 0. I've got an a value of -16, a b value of 10, c value of 16. Again, solve this equation on your own, please. When you get to the discriminant, you should be getting a discriminant of 1124, so make sure that's what you're getting. And then when you get down to your solutions and check them in your calculator, you should be getting -0.7 and 1.4. Again, this is time. Time for the diver to hit the pool, and negative time is irrelevant. And we're going to have a sentence like, it took the diver 1.4 seconds to hit the pool. So somewhere in your answer you should have the value 1.4 seconds. Okay, last one. This one's a little bit trickier. I'm going to show you that it's not that difficult to solve if you understand what to do, and hopefully I'll be able to explain it to you and make logical sense. We've seen problems like this before, but pretty rare. Your friend shoots a basketball If a is negative 5 meters per second squared, so we know, class, our height's going to be measured in meters, and our x-axis is going to be time because it has seconds. The initial height was 2 meters, and the initial vertical velocity was 10 meters per second. At what time will the ball be 3 meters above the ground? So now we don't care if the ball hits the x-axis. We want the time that the ball is going to be 3 meters above the ground. So take a look at that. If I had a parabola, and here is my basketball going up and then coming back down again over time, we don't want to know where it hits the ground. We want to know, where is the basketball 10 meters above the ground? If that was our y-axis, that'd be 10. 10 meters above the ground. Sorry, not 10 meters. How about 3 meters? I was thinking to myself, 10 meters. Wow, what am I doing? That's 30 feet almost. It's 3 meters above the ground. So you can see we got to do a little trick here, a little math trick to actually do the same thing that we normally do with quadratic formula to find the x-intercepts, but we're going to actually shift the parabola down in order to get these 2 points to line up on the x-axis, and we can find the solutions just like we would finding x-intercepts. So let's go ahead and write our equation. Well, here's our a value. The initial height was 2 meters. That is our b value. Sorry, initial height is our c value. And our vertical velocity, our initial velocity, is our b value. So our equation is going to look like this. Y is equal to negative 5, I'll just use x squared, plus 10x plus, not 3, let's be careful. Our initial height is 2 meters. There's our equation. Gravity, negative 5, initial velocity, 10, initial height is 2 meters. Well, we're going to use the quadratic formula. Let's set this equal to 0, but I'm going to stop before I do that and watch this. 5x squared, actually let's write it out like we normally would. Now here's our situation. We don't want to know when the ball hits the ground. That would be at y equals 0. We want to know when the ball is 3 meters above the ground. So watch what I'm going to do. Instead of putting a 0 here, we're going to make this a 3. Now our equation is going to help us solve for when the ball is 3 meters above the ground. Now all we have to do now is follow our rules of quadratic formula. All the terms have to be on one side of the equal sign. So let's subtract 3 from this side and subtract 3 from this side, and now we're going to end up with negative 5x squared plus 10x. 2 minus 3 is negative 1. 3 minus 3 is 0, and now you see, class, we have modified our equation. What we technically did was we took the parabola and we shifted it down 3 units, so now these 2 points are actually on the x-axis, and now we can solve just like we would find x-intercepts, only we're going to actually find out when the ball reaches 3 meters above the ground. So you can just go ahead and do your normal routine now. You're going to find A, you're going to find B. Now our C value is negative 1. Again, I'll give you solutions to this, but you need to work them out yourself. Your discriminant is going to end up being 80. And your solutions, now what you expect here, look at our graph. I would expect to have 2 positive solutions because the ball is going to start going up and cross 3 meters. And then it's going to get to its vertex, start coming back down again, and cross 3 meters again. And that's exactly what happens. When you find your solutions, you're going to see you have 2 positive solutions. It crosses 3 meters very soon at 0.1 second, and then it hits the vertex and comes back down. Your other solution will be 1.9. So when you answer the question, because it says at what times will the ball be at 3 meters, you're going to be saying the ball will be at 3 meters. The ball will be 3 meters high at 0.1 seconds, and your answer should also have 1.9 seconds. Again, if you want credit for this worksheet, you have to work out the solution, use my help to verify that you got the right answer, and then write your final answer in a complete sentence to get full credit. All right, that is the end of our test review.